couple examples of electron configuration and then the shorthand electron configuration, also known as the noble gas configuration. So I have a couple things that are helpful here for you. Not only do I have the maximum number of electrons that each of the orbitals can hold, you also want to have in front of you the Aufbau principle, that mnemonic that we covered in class, or that you have in front of you on your handout. That's going to be really critical. You don't need to memorize it. That's something that's going to be provided for you. So you're going to fill in the electrons starting with the lowest energy level, which is always 1s, and you're going to ultimately fill it up to the maximum number of orbitals that you need to find a home for all of the electrons. So let's start with copper. If you find copper on the periodic table, its symbol is uppercase C, lowercase u. And so copper on the periodic table, you want to find its atomic number. And copper has an atomic number of 29. So that means that as an atom, copper has 29 electrons that you need to find a home for. Let's go ahead and take a look at potassium. Potassium is letter K on the periodic table. Potassium has an atomic number of 19, so when this is an atom, it has 19 electrons as well. We're going to focus on those two to begin. And so the way this is going to work out is you're going to use your Aufbau principle and you're going to fill in the electrons as needed in order of lowest energy level to progressively higher energy level. So let's start with copper. We have 29 electrons to fill in. We're going to start with 1s, that is my lowest energy level, and I'm going to put 2 electrons in 1s. My next energy level following the Aufbau principle is 2s. I'm just following the arrows and the lines. Again, I'm going to fill in 2 electrons. My next energy level is 2p. P can hold a maximum of 6. I'm going to take all 6 locations. I need 6 electrons in 2p. My next energy level is 3s. I'm going to fill it in all the way, 3s2. I'm going to continue following my Aufbau principle, and I'm going to continue filling it in, so 3p6. Now I can move on to 4s2. Now, remember, I need 29 electrons, so I don't want to overfill. Once I get to 3D, that's my highest energy level that I've completed so far, D can hold a maximum of 10 electrons, but I don't have 10 to fill out. I just need to fill out 9. So this is now my electron configuration for copper. I'm going to do the same thing with potassium. I'm going to use my Aufbau principle to fill in order, going from the lowest energy level first, working up to the highest energy level needed based on how many electrons I have. So if I start with potassium, I always start with 1s, and so I'll always start with 1s2, unless I'm looking for hydrogen. Hydrogen would be 1s1 because it only has 1 electron. But potassium, I need 19 electrons. I just found a location for 2 of them, so 1s2. I'm going to continue using the Aufbau principle, and so again, I'm going to now follow up and go into 2s, and so that's going to give me 2s2. I continue filling it in, 2p6, 3s2, 3p6, and remember, I only need 19 electrons, so my next orbital is 4s, but I don't need 4s2 because that would give me 20 electrons. I just need 19 electrons, so that's 4s1. So now I have my electron configuration for copper and for potassium. I'm going to go ahead and look at my noble gas configuration for chlorine. And so chlorine on your periodic table, this is number 17. So that means chlorine will always have 17 electrons unless you're looking at chlorine as an ion, which in this case we're not. So what you want to do for noble gas configuration is you want to go to the noble gas that occurred before chlorine. Find the noble gas on the periodic table that occurs before chlorine, and that happens to be neon for this particular element. So neon holds all of my Aufbau principle electrons. Neon, normally, if I were to write it out, neon would be 1s2, 2s2, 2p6, not 3s2. I've gone too far. So this right here is my electron configuration for neon. Instead of writing all this out, all I'm doing is putting neon in my brackets. And that represents me writing out the noble configuration up until 2p6. But remember, chlorine has 17 electrons, so I'm not done here. So after 2p6, I now need to go into 3s and then ultimately 3p and 4s if I needed to, which I won't for chlorine. But neon ends at 2p6, so now I can go back to my Aufbau principle. What comes after 2p? 3s. And I'm going to fill in 2 electrons into 3s. I now just need to fill in a couple more electrons, and so I need to go to my next orbital, which is 3p, and I'm not going to fill in the max, which is 6, I'm just going to fill in 5, and now I have a total of 17 electrons represented for chlorine.